They have mystified astronomers for more than a decade, but the source of repeating alien signals, known as fast radio bursts, FRBs, may finally have been found. The incredibly strong pulses seem to come from a black hole or an orbiting neutron star with unprecedented power 3 billion light-years from Earth, experts say. Scientists believe the findings suggest the discovery of an extreme environment, which is among the most highly magnetized regions of space ever observed. However, experts are still not ruling out more unorthodox explanations such as signals coming from an alien civilization. Advertise and get read invented by Teed. Scroll down for video plus 5 and guide. D equals IE 17 CDA 5 D42 D35 F80 SRC equals http://i.dailymail.co.uk/i/pics/2018/01/10/16/47 FC8030005785255 height equals 444 width equals 634 alt equals the source of repeating fast radio bursts generated by the object known as FRB 121102, picked up by telescopes here on Earth, may come from a black hole or neutron star with unprecedented power. $3 billion light-years away. Artist's impression. Class equals blocks bordering share, greater than fast radio bursts. Fast radio bursts, or FRBs, are radio emissions that appear temporarily and randomly, making them not only hard to find, but also hard to study. The mystery stems from the fact it is not known what could produce such a short and sharp burst. This has led some to speculate they could be anything from stars colliding to artificially created messages. The first FRB was spotted, or rather heard by radio telescopes, back in 2001 but wasn't discovered until 2007 when scientists were analyzing archival data. But it was so temporary and seemingly random that it took years for astronomers to agree it wasn't a glitch in one of the telescope's instruments. Fast radio bursts, FRBs, are brief, bright pulses of radio emissions, from distant but so far unknown sources. They were first detected in 2007 by astronomers scouring archival data from Australia's Parkes telescope dating back to 2001. The 64-meter, 200-foot, diameter dish, is best known for its role receiving live television images from the Apollo 11 moon landing in 1969. But the antenna's detection of the first FRB, and the subsequent confirmed discovery of more than 24 of the powerful radio pulses across the sky, left astrophysicists baffled. The catch with FRBs is that they are mostly random and they last for only a few milliseconds, too fast to routinely detect or conduct follow-up observations with radio and optical telescopes. Only one FRB has been found to repeat, an object known as FRB 121102 in a galaxy about 3 billion light-years away. More than 200 high-energy bursts have been observed coming from FRB 121102, since it was first detected in 2012. An international team of researchers, which included the Breakthrough Listen Search for Extraterrestrial Intelligence (SETI) team at the University of California, Berkeley, used the Robert C. Byrd Green Bank Telescope in West Virginia to study FRB 121102. They found that the electromagnetic waves that make up the bursts generated by the object conform to a highly unique pattern. This means they came from somewhere with an incredibly strong magnetic field, like that found around a black hole or neutron star. Such patterns have only ever been seen in radio emissions from the extreme environments around massive black holes, such as those at the centers of galaxies. Victoria Caspi of McGill University, who was part of the study, said, "I had to read my email a few times to really digest it. I kept thinking, no way, that can't be right. We found something that is clearly in an extreme place, and the extreme location may create a phenomenon that is one of the biggest astrophysical mysteries of recent times. If you have an extreme object in an extreme environment, is that just a coincidence? FRBs have these huge explosions in radio waves and we don't know why that occurs. Maybe this is a clue to the mechanism that produces these explosions." The findings confirm observations by another team of astronomers from the Netherlands, which detected the polarized bursts using the William E. Gordon telescope at the Arecibo Observatory in Puerto Rico. The Dutch and Breakthrough Listen teams suggest that the FRBs may come from a highly magnetized rotating neutron star, known as a magnetar, in the vicinity of a massive black hole that is still growing as gas and dust are sucked into it. UC Berkeley postdoctoral fellow Vishal Gaijar of Breakthrough Listen said, "At this point, we don't really know the mechanism. There are many questions, such as, how can a rotating neutron star produce the high amount of energy typical of an FRB? Another possibility, though remote, is that the FRB is a high-powered signal from an advanced civilization. Hence, the interest of Breakthrough Listen, which looks for signs of intelligent life in the universe, funded by US $100 million, £75 million, over 10 years from internet investor Yuri Milner. +5 mguide.d. equals I977F3A52762E2895 SRC equals http://.dailymail.co.uk/I/10/16/01/10/16/47FC802C000057852555047 while _exact_nature_scientists_still_unknown_most_core exact_score nature_think_a4_1550367776.jpg height equals 396 width equals 634 alt equals the incredibly strong pulses may come from a black hole or neutron star. Artist's impression, with unprecedented power inverted ? 3 billion light-years from Earth. Experts say class equals blocks bordering share, greater than Dr. Gaijar added, we cannot rule out completely the ET hypothesis for the FRBs in general. The short bursts, which range from 30 microseconds to 9 milliseconds in duration, indicate that the source could be as small as 6 miles, 10 km, across, the typical size of a neutron star. A neutron star is the collapsed core of a large star which had a total of between 10 and 29 solar masses before it collapses. They are the smallest and densest stars known to exist. A magnetar is a type of neutron star with an extremely powerful magnetic field. Experts say that other possible astronomical sources for the FRBs are a magnetar that is interacting with the clouds of particles it shed when the original star exploded to produce it. They could also be produced by a magnetar interacting with highly magnetized winds produced by a rotating neutron star or pulsar. Breakthrough Listen has so far recorded data from a dozen FRBs, including FRB 121102, and plans eventually to sample all 30-some known sources of fast radio bursts. Alien explorers could be behind mysterious FRBs. Mysterious signals coming from distant galaxies could be evidence of deep space explorers billions of light-years from Earth, a new study has claimed. Researchers from the Harvard-Smithsonian Center for Astrophysics claim a solar-powered transmitter using sunlight cast on an area twice the size of Earth could generate enough energy to be seen by far-away viewers. And, a water cooling system would allow a device of this size to withstand the extreme heat. The researchers argue that the most plausible use for this tremendous amount of power would be to drive interstellar light sails. The light sail would rely on a steady beam from the transmitter. While this would always be pointed at the sail, observers on Earth would see it as a brief flash, as the sail, its host planet, its star, and the galaxy all move relative to us. This would cause the beam to sweep across the sky, only pointing at Earth for a moment. The project allotted tens of hours of observational time on the Green Bank telescope to recording radio emissions from FRB 121102, and last August detected 15 bursts over a relatively short period of 5 hours. They analyzed the two brightest to make the discovery about the FRB's unique orientation. Now, the team plans more observations of FRB 121102 before moving on to other FRB sources. Dr. Gaijar said that they want to observe at higher frequencies, up to 12 GHz, versus the present Green Bank observations in the 4 to 8 GHz range, to see if the energy drops off at higher frequencies. He believes that this could help narrow the range of possible sources. He added, "We want a complete sample so that we can conduct our standard SETI analysis in search of modulation patterns or narrowband signals, any kind of information-bearing signal emitted from their direction that we don't expect from nature." The full findings are detailed in a combined paper published online by the journal Nature. Scientists believe FRBs occur much more frequently than they have been observed. Some estimate that there are as many as 10,000 FRB events per day coming from all directions in the sky, Plus 5 in guide.d. equals I16E6C61 EQ1A697 SRC equals http://guide.dailymil.co.uk/IPix/2018/010/16/47FC80360005785255047 image A3_15156031478.jpg height equals 424 width equals 634 alt equals experts found the FRBs generated are nearly 100% linearly polarized. Such a pattern has only ever been seen in radio emissions from the extreme magnetic environments around massive black holes, such as those at the centers of galaxies. Artist's impression, class equals blocks border image share, greater than the mystery stems from the fact it is not known what could produce such a short and sharp burst. If the mysterious phenomena is indeed a sign of intelligent life in the universe, the latest findings could suggest it is far more widespread than previously thought. Researchers from the Harvard-Smithsonian Center for Astrophysics, CFA, have estimated how many FRBs should occur over the entire observable universe. Their work indicates that at least one FRB is going off somewhere every second. When FRBs were first detected, astronomers had never seen anything like them before. Since then, they have found a couple of dozen FRBs, but they still don't know what causes these rapid and powerful bursts of radio emission. Plus 5 in guide.d. equals IBD062D3457CF8 SRC equals http://guide.dailymil.co.uk/IPix/2017/09/4495010005784909344 the underscore blue underscore points underscore and underscore this underscore artist underscore s underscore impression underscore of underscore the underscore filamentary underscore SA5 underscore 1506069693731.jpg height equals 410 width equals 634 alt equals scientists searching for fast radio bursts, FRBs, that some believe may be signals sent from aliens may be happening every second. The blue points in this artist's impression of the filamentary structure of galaxies that extends across the entire sky are signals from FRBs. Class equals blocks border image share, greater than Anastasia Fikov of the CFA, who led the study, said, if we are right about such a high rate of FRBs happening at any given time, you can imagine the sky is filled with flashes like paparazzi taking photos of a celebrity. Instead of the light we can see with our eyes, these flashes come in radio waves. In the time it takes you to drink a cup of coffee, hundreds of FRBs may have gone off somewhere in the universe, added study, co-author Avi Loeb. If we can study even a fraction of those well enough, we should be able to unravel their origin. To make their estimate, the scientists assumed that FRB 121102, a fast radio burst located in a galaxy about 3 billion light-years away, is representative of all FRBs. Because this FRB has produced repeated bursts since it was first observed in 2002, astronomers have been able to study it in much more detail than other FRBs. Plus 5 in guide.d. equals IAED31D883A422336 SRC equals http://guide.dailymil.co.uk/pix/2017/09/22/09/44950105784909344 image A2 underscore 1506066965619.jpg height equals 431 width equals 634 alt equals if the mysterious phenomena is indeed a sign of intelligent life in the universe, it could suggest it is far more widespread than previously thought. Data from the FRB 121102 was gathered using the Green Bank telescope, pictured, class equals blocks border image share, greater than Y study FRBs? Researchers from the Harvard-Smithsonian Center for Astrophysics point out that FRBs can be used to study the structure and evolution of the universe whether or not their origin is fully understood. A large population of faraway FRBs could act as probes of material across gigantic distances. This intervening material blurs the signal from the cosmic microwave background, CMB, the leftover radiation from the Big Bang. A careful study of this intervening material should give an improved understanding of basic cosmic constituents, such as the relative amounts of ordinary matter, dark matter and dark energy, which affect how rapidly the universe is expanding. FRBs can also be used to trace what broke down the fog of hydrogen atoms that pervaded the early universe into free electrons and protons, when temperatures cooled down after the Big Bang. Using that information, they projected how many FRBs would exist across the entire sky. While their exact nature is still unknown, most scientists think FRBs originate in galaxies billions of light-years away. One leading idea is that FRBs are the byproducts of young, rapidly spinning neutron stars with extraordinarily strong magnetic fields. Fyodkov and Low point out that FRBs can be used to study the structure and evolution of the universe whether or not their origin is fully understood. A large population of faraway FRBs could act as probes of material across gigantic distances. This intervening material blurs the signal from the cosmic microwave background, CMB, the leftover radiation from the Big Bang. A careful study of this intervening material should give an improved understanding of basic cosmic constituents, such as the relative amounts of ordinary matter, dark matter and dark energy, which affect how rapidly the universe is expanding. FRBs can also be used to trace what broke down the fog of hydrogen atoms that pervaded the early universe into free electrons and protons, when temperatures cooled down after the Big Bang. It is generally thought that ultraviolet, UV, light from the first stars traveled outwards, to ionize the hydrogen gas, clearing the fog and allowing this UV light to escape. Studying very distant FRBs will allow scientists to study where, when and how this process of ionization occurred. FRBs are like incredibly powerful flashlights that we think can penetrate these fog and be seen over vast distances, added Dr. Fyodkov. This could allow us to study the dawn, a universe in a new way. Is this proof aliens exist? 250,000-year-old aluminium found loaded, 0% progress, 0% 0:00 previous play skip live immute 00:00 current time 0:00 duration time 1:03 full screen need text video quality 576p 540p 360p 270p foreground, white black red green blue yellow magenta cyan, opaque semi-opaque background, white black red green blue yellow magenta cyan, opaque semi-transparent transparent window, white black red green blue yellow magenta cyan, opaque semi-transparent transparent font size 50% 75% 100% 125% 150% 175% 200% 300% 400% text edge style none raised depressed uniform drop shadow font family default monospace serif proportional serif monospace sans serif proportional sans serif casual script small caps default stun minimize